Welcome my dear friends to sharmaclassesnagpur.com. Here is problem number 5 now on successive differentiation, and the logic remains same throughout. So the very first step, we know that we should express y in its simplest form, and in its simplest form this y is in terms of log. So we should remove log from here, and in order to remove log from here, we know log and exponential function are inverse of each other. So when log goes from left to right, it becomes log inverse in a way, that is e, and e raised to the rest thing to the right becomes e raised to, so it becomes e raised to m cos inverse x. So this becomes now our equation number 1. Okay, now rest things remaining same, differentiating with respect to x, y becomes y1, e raised to anything is e raised to same thing initially, into chain rule, into d by dx of whatever is raised to, m is constant, cos inverse x, it is minus 1 by 1 minus x square. This is minus, clearly we should feel its minus thing. So now cross multiplying, cross multiplying 1 minus x square y1 is equal to minus m e raised to m cos inverse x. Now, so this is now equation number 2, in which there is a y1. Equation 1 is alone always with respect to y. Now again differentiating this thing, differentiating equation 2 now with respect to x. Product rule to the left side. See here, algorithm remains same throughout. First function as it is into differentiation of y1 is y2, plus second function as it is into differentiation of under root is chain rule again, 1 by 2 under root 1 minus x square into minus 2x. Now 2 gets cancelled, and right side one is minus m is k, e raised to anything is e raised to same thing initially, whatever, however lengthy it is, into d by dx of raised to thing, in which m is constant again, and cos inverse is minus 1 by 1 minus x square. So now taking LCM here and cancelling with root 1 minus x square here as well as here, so it can get simplified now. So 1 minus x square y2 minus x times y1 is now m into m is m square minus minus plus m square, and whatever this is remaining, see here, e raised to this from 1, as usual algorithm from 1, we can write down its value as y, and denominators I am thinking as if we have cancelled it. After taking LCM, I can cancel this with total this. Okay, so, or in other words, if I want to take a simplest LCM form, then I am dividing this and multiplying also with the same thing. So this is root has become now square, so now it is without root over here. Y2 minus xy1 is m square y, and thereafter I have cancelled these thing. Green pen, this both are being cancelled from this thing. So this is equation number 3 for us, which is containing y2, because this will be helpful to us in the next Maclaurin series. That equation number 1 is purely containing y, equation number 2 is a function having y1, equation 3 is having y2. Now we will apply Leibniz. Now we will apply Leibniz. Applying Leibniz to equation 3. Applying Leibniz theorem to equation 3. So first we will take these two functions x and y. X function as it is, y of n plus 2 plus n differentiation minus 2x integration in a way that is plus 2 minus 1, or decrease number by 1 always, plus n into n minus 1 by 2 factorial into minus 2, n plus 1 is only n now. Okay, now it's turn of these two things with a minus sign common. Let's not take the risk, draw a square bracket for better understanding. X y n plus 1 plus n, x differentiation is 1, y n now, over round this thing, and again the same thing, is equal to is given. I am writing minus as usual every time. Minus m square was constant, and y differentiated n times is yn equal to 0. Now final step, as we know, first term is same always for us. So 1 minus x square y n plus 2. I am taking common from second and fourth, x y n plus 1. Minus is also common over here, so I am taking minus. I am left with 2n plus 1 here. 2n plus 1 x y n plus 1. Here too, this 2 cancels with this 2. If I take yn common from 3rd, 5th and 6th, then we are left with this minus. Here also is there, and in this case also it's minus. All the three are with a minus sign, so I am taking minus common, and yn is also common. And now n square minus n, this is now plus n, again it is m square n yn, this is equal to 0. Minus n plus n gets cancelled, and hence the result we can see 1 minus x square yn plus 2 minus 2n plus 1 x yn plus 1 minus m square plus n square plus m square, both are same, hence proved. Thank you my dear friend.